The crystal structure of the ribosome reveals many insights into the molecular mechanism of translation. Zooming in on the large ribosomal subunit shows highly evolutionarily conserved RNA bases lining the active site of the peptidyltransferase center, which catalyzes polypeptide bond formation. There are no ribosomal proteins in the vicinity. Peptide bond formation is catalyzed in an environment exclusively made of ribosomal RNA. The 3' end of a tRNA charged with an amino acid is bound in the active site. This amino acid represents the carboxy-terminal amino acid of a growing polypeptide chain on an actively translating ribosome with the peptidyl tRNA bound to the P site on the ribosome. Conserved bases common to the 3' end of all tRNAs base pair with the ribosomal RNA to position the amino acid precisely. The incoming amino acid linked to its respective tRNA binds closely, again held precisely by base pairing interactions between a conserved base on the tRNA and ribosomal RNA. A network of hydrogen bonds positions the reactive groups with the precise geometry required to catalyze peptide bond formation. The empty deacylated tRNA is released from the P site. During the translocation step of protein synthesis, the other tRNA, now containing the growing polypeptide chain, moves from the A to the P site, where it will be waiting for the next incoming amino acid to repeat the polymerization cycle. The different states of the reaction cycle shown in this animation are based on actual crystal structures, in which large ribosomal subunits were crystallized with various aminoacyl tRNA analogs bound to them, mimicking the discrete steps in the reaction cycle.